Hello and welcome to the ABAP Objects Introduction or Refresher course. This is really intended as a preparation for the Agile Software Engineering course, where we will do a lot of programming in ABAP OO to write unit tests. The purpose of this little course is really to prepare you for the Agile Software Engineering course, like I said. And if you haven't done a lot of OO programming lately, this is a good way to refresh your memory. That is one thing, but also the second point is that maybe you are used to writing global classes, and for unit tests we will write ABAP objects classes completely source code based, and this is something that not everybody is familiar with. So also in preparation for that, for the course, this is one reason why you should take these, look at those examples. The format is that it's a self-study course with a set of modules where in each we have a little video to introduce some concepts. There's a programming exercise and a short video that looks at sample solutions, so sample code, what things could look like. And of course the modules build on each other. Here you see the list of modules. This is roughly the way it's going to go, and we will just dive right in with module number 1. Before, it's important to say again what are the assumptions. So we do assume that you are an experienced ABAP developer that is familiar with ABAP programming, at least the non-OO kind, and all the tools that are needed, and of course also that you have access to a system to really do the exercises. As far as the positioning, again, the course is really not a substitute for any real OO course that where you learn a lot of things, and it's also not complete in any sense with respect to the ABAP objects language, but just like a minimal way to get started, at least for the course purpose that we're looking at. So if you really want some deeper study, you definitely should get the ABAP Objects book, which is the complete reference of all what the language has to offer and the environment. And then here we also show you 2 good books about patterns, so object-oriented patterns that for use in all kinds of circumstances. That's also really good and important thing to know. So, but let's get started with the ABAP Objects module number 1. And the first point is really how do we get from functions to objects. So assuming that you're familiar with the procedural programming module, you know that of course there is a separation of data and function in the programming world. Data represents the state of real-world objects, and functions implement behavior. So and there's a hierarchy in both. So for clearly in the functions, one function calls another, and if you write some well-structured code, maybe you have some layers and so forth. And then also in data there's often some kind of hierarchy, or at least relationships where one data element points to another, for instance by keys. Certainly on the database this is the case. So the point is though that in general there's nothing that prevents you from any function truly to access all data. So you can encapsulate data access by functions by convention. For instance, you say, I only want to access this data through this form routine or through this function. But it's a convention that is not enforced by the system. And so you may have code really there where there's a lot of dependencies between a lot of different places that are hard to manage. Because in general, all data is accessible to all functions. Now, one thing is also in this in the procedural world, how do you deal with multiple instances? So for instance, if you have an order and you have multiple items and you want to deal with those items, then of course, okay, you have to have a table of items. That is, a row in a table holds the data for one instance. Instance, I mean like instances of different logical objects. And so to work on the current instance, I have to either to address this in some way, either by a field symbol or by taking a row into a work area. So first I have to find it, then make it accessible by setting the field symbol to it, or taking it into the work area. And it makes it really hard to also address multiple current instances you work with. So you maybe have multiple field symbols, or you have only one work area of a table normally, so you'd have to copy it out and so forth. This is not so easy to do. And it's also hard to have deeper structures. So if you think, for instance, an order and an items table, and maybe you have sub-items, then you have maybe nested data structures with nested tables, which is really getting typically very nasty. Now, to get a new instance, again, coming back to this example of how do you deal with instances, is you append to the table. So if you look at this table example here, we have a table of cars, and there is one car, each car is one table, and so you have here one car that's a Porsche and another car that's a VW Bug, and they have certain attributes that are stored. So a row is typically identified by a key, and each instance is represented by one row in this table. Now, going to objects, what really changes? The key idea is, if you look at the top right there, is to put code and data together. So the functions, so to speak, and the data. And the idea is that you have the data in a private section, and the forms or functions are called methods now. Or the data is called instance attributes. And what really happens now is that the methods, so representatives of former functions or so, they work only on their object's data. And they keep it, so the object typically can keep their own object data hidden, and definitely the methods can keep it consistent. So you are not in danger that somebody a client on the outside sets some data element and creates an inconsistency for you as the code that wants to manage this data. And so usually the methods are public and data is hidden, so that you can guarantee that the data is kept consistent. And there's other benefits to that as well. And so you can see below a little in the middle there, for instance, you can have a class car where there are two methods, set name and set speed, and there is some attributes, name and speed, that is hidden, and that is that's data that is kept. So the class is like the code and the data definition together. And this is what we call a class. So you have the attribute definition and the methods, and then you can have that defines how the class behaves, what it looks like, and so forth. Now, if you want an instance, an object instance, and like we said before, in the old world we used table rows for that. We have a different statement now that's called create object instead of append line. And what you get is two instances, two copies, so to speak, of this class car. Now the code exists only once, of course, but since the code only works on its own instance, it looks like every object has their own code, and that's how you access this data. So in reality, each object has its own data, and the code works only on that data of its own object. So a class is what we call the code plus a structure to define those objects, instances that we get from. An object, or alternatively instance, is what we call the concrete instance of a class. So we have one class and many instances of this class. In this case, two cars, for instance, two car objects. How does this look in the code? You're all familiar with the normal code, so I'll just point out what is different. And this is how you would write it in a local class definition. So there's a class statement that defines a class just like you would otherwise expect a function statement to define a function or a form statement. So the class has a class name definition, then there's a public section which we'll come to later, and then methods introduces the section where you define methods. And the syntax there is very similar to functions. So you have a name and then importing and parameters and type and so forth. And then you see also there is a data definition, just like anywhere else in the code you can define data. You see here there is a data name type string, current speed type integer, and this is where you define the data of this class. And you can guess there is a public section and private section. Protected we'll come to later, but the data is private, so you can't really see it from the outside, and the methods are public, and you can see and use them from the outside. So this is the definition, which means this is what the car class looks like from the outside. And now something is missing, that's the implementation. And this is also one thing that is different from like function code. There is a separation of a definition of something and then the implementation. And here you see the implementation class. It says class, same name of implementation. Typically you put that below, and you have to because the definition needs to be there before. And then you have method and method statements for each method that needs an implementation. So you have the set name, and it gets an iname as a parameter, and just assign it to that attribute. Really simple. So we have class definition, class implementation. In the implementation, we have only the method implementations with their code. And then you want to, of course, look at how do I use this stuff, right? How do you use these classes? And so we look at the client code. Client code is code that would use these objects. And so first of all, we see below there's a data definition again, but now there's something new. Type ref2 LCL, which by the way means local class, so local class car. So what we're doing here really is to define a reference variable that can hold a car. And there's two variables. There's a Mercedes variable and a Porsche. And they're initially empty. So it's like, if you will, an integer with a value 0, except there is a reference that is now defined as a reference, but there's nothing in it. Now, the create object statement creates a new instance of a class. So we say create object Mercedes, which will create an object of type class LCL. As LCL car. And the same thing, create object Porsche will also create an instance of type LCL car. So now I have two of them, and they're in two different variables, the references. And to make, obviously I want to keep them separate, so and distinguish them somehow. I can, for instance, call a method on them. And so what method I have is defined up there. It's a set name. So I'll tell the Mercedes instance that its name is now Mercedes Viano, for instance. And the Porsche instance that it's a Carrera 901, 911. So this is how you create objects, and that's how you call method. You just type the reference variable, arrow, so dash greater, and then the method name, and then parentheses and the one parameter. So this is a short form that you can use if you have only one parameter for a method. We'll come to that in more detail later. So this is roughly what OO code looks like. There's a definition of a class, there's an implementation of a class, and the client code uses it by references and method calls. And sometimes, if attributes are public, you can also access attributes directly. There is one very important concept here of object orientation, and that's the so-called reference semantics. And what this means is this, that if you create, let's say you look at an example, they have three variables, car 1, 2, 3. And those are reference variables. They all are of type ref2 LCL car. I can put a car object into it. And so now I'm going to create all of three of them, car 1, 2, 3, and create objects. Now, that little piece of code, of course, doesn't create different cars, but let's assume I'll add some things like set name and color and brand or whatever. So we really have three different cars, also from the attribute values in those three variables. Now, object references are how you access an object. So an object is accessed via a reference that points to this object instance. And what's special, it's like a field symbol. Yeah, you can have two field symbols pointing to the same thing. And references are stored in reference variables of type ref2 and then class name. Also, these are typed so that only references to this type of objects can be stored there. So you won't find like a car or a truck there, but it can only an object of type LCL car can be stored in there. Now, one thing is important about the reference semantics. Look at the statement below where it says car 3 equals car 1 and then clear car 2. Those two here. Car 3 equals car 1 copies the reference. So now car 3 has the same reference as car 1 and they both point to the red car, whatever that is. Clear car 2 resets the reference variable of car 2, so there is nothing in it right now. Now what happens is car 1 and car 3 both point to the same instance, the red car, and the other two cars are not accessible at all anymore. Those are objects, they're free floating in memory, and they are no longer reachable. This is what garbage collection is about. This is what the system also does, is that it looks that objects that are no longer reachable by any reference, they are reclaimed, which means the memory where they're stored will be reused for new objects. If you want to compare that to the old world somehow, you can say references are like field symbols. Of course, you can have two field symbols that point to the same thing, but instead of the field symbol always pointing to a static data area that somehow really lives only once, and that you can just select, for instance, like a table row or even a local variable or something. Objects are created dynamically, and you can create as many as you want. And then if you take the reference away and the object is no longer reachable, then it will be reclaimed automatically. So this is definitely different behavior. If you would now, for instance, take car 3 reference away and say you have another statement, clear car 3, car 1 is still holds a reference to the red car, so the red car will not be reclaimed. When you also clear car 1, also the red car is not reachable anymore, and then also that will be reclaimed. So this is really important to know. When you do assignments of objects in reality, you're always doing assignments of object references. And that means that you point with 2 references to the same object. It doesn't mean that you copy the data that's within the object. One other key concept of objects is really encapsulation and the distinction between public and private. I alluded to it before that in this car, for instance, example, we have a public section and a private section. The public section is where you define methods, and the private section is where you can define things that are not supposed to be seen by the client. Now, technically, you can define anything you want, methods, data, and even events, which we will not cover, and all kinds of things, types, in the public section and in the private section. And the idea is that everything that's public is visible to each client. So anybody who uses this car sees that, whatever you define in there. They can be methods, data, types, whatever. But the private components, and again, that can be data, methods, and anything, they are not visible. And so if you use from a public method, you call a private method and a whole bunch of private methods, you can change those private methods without having to fear that anybody uses them, and you may break some client code. Because it's private to the class, you can restructure it, you can restructure the data and private elements without anybody on the outside getting hurt, so to speak. So as a design principle, which is also one of the main reasons why really objects were invented, is that you want to keep your data private, since private data structures can be modified within the class. And the methods of the objects that are public, they are the ones that provide the functionality, but they are also the ones that ensure the consistency of the object's data. So you're responsible, and you can ensure that your data keeps consistent if at least, if you write your object methods correctly. So as a rule of thumb, methods, only methods should be public and data should be private, and of course you can also have in addition private methods as well, like as helper routines and so forth. Now there's a special method called the constructor. And this method is called implicitly by the system when an object is created. So if you say create object and the class that you're creating has a constructor defined, it will be implicitly called. And now you can also define parameters on this constructor, which means now, of course, then you have to pass, if the parameter is defined, then you pass it on the create object. So you can see in the definition up there, methods constructor, it just means if you use the name constructor, then it means I am basically redefining the previously default definition of constructor without parameters, and I'm saying now I want a real constructor, I want to implement a constructor method, and I want an iname with type string as an argument. And of course then you have to implement this as before, and when you call is really not the right word. If you create an object, you have to specify the parameters. So this is what you see in the second piece of code below. Create object, reference variable name, in this case Porsche 911, exporting Porsche Carrera 911. So that's where you specify the name. The point is, why do you need a constructor? Really is that, first of all, they are optional. You don't need to do that. But they're usually used to initialize an object to some consistent state. So if you have an object that has a complex state and you want to make sure that whatever internal variables are initialized correctly, and this is just another case of the client cannot break you as a class, then the constructor can set everything up right, and then the methods after the constructor will keep a consistent state. So in the constructor you can do basically hide initialization statements that you need. Now we're ready to do the first exercise, which is really where you get to try out some of these basic OO concepts and syntax. And the semantic exercise, so what we're really trying to do is here we'll try to model different kinds of cars with their fuel consumption. So practically what you do to do this is you create a program report in the $temp area where you write your local classes in. As I said before, if you're familiar with the SE24 class builder, we're not going to use this. We're going to look at it later in a demo. But we will only write local classes, so basically local classes and a start of selection main few statements to use those in a little program. So create any report program in $temp, and that's when you can write these exercises in. What you have to do is define in the further instructions here. So you're supposed to define a local class for the car, and let's stick to the naming convention. L is for local, CL is for class, underscore, and then you have a name of whatever you're trying to model. So LCL car in this case. You will have some attributes. You need to define the name of the car. We also want to have a capacity of gas tank in liters, the fuel consumption, how many liters per 100 kilometers of of distance, and the current tank level in liters. Actually, yes, the current tank level in liters that you have left in the tank, so to speak. And now you also should define some methods. So first of all, a constructor, as we just said before. And with the constructor, we want to pass the name, capacity, and fuel consumption as 3 arguments that we always want each object to have, each car object, to make sure that we never forget to set them. So we'll make them constructor arguments, and we'll be setting them at the time when we say create object, those 3 attributes. So in the constructor, you will have to set the attributes, of course, from the parameters. Then you should make a method refuel, which fills up the gas tank and returns the number of liters used to refuel. So how many liters did you add to the tank? Drive distance simulates that you drive with this car a certain amount of kilometers, and of course this reduces the gas in the tank until it's empty, and then you stop. And then you can call the car and ask, what is your current tank level? And this we want to get back in percentage, so 0.35 means 35% filled, and that returns the current tank level in percentage. And in the main program where you use this object, this class of class LCL car, you should create 3 different cars with 3 different tank capacities and gas consumptions, whatever you come up with, doesn't matter. Call those methods on these objects to drive various distances, and then call methods to ask for the current tank level and see if they are okay, and output these values. For instance, you can use write statements. It's probably the easiest. To make it simple, excuse me, to make it simple, to make it simple to find yourself, how to use the ABAP object syntax, there is a slide here in the end I will jump to right now, the ABAP object syntax reference by sample code, and here you see almost copy-paste wise you can copy the code and then don't have to mess with read the books or anything on how to write things exactly for the class definitions and the implementation and so forth and usage of classes. And so you can look at this. Since you have the slides, you can just keep this handy, this slide here, slide number 43, while you're doing the exercise. This program is also contained in the demo system as ABAP ASE OO intro lang ref, so language reference. Oh, that was a jump to the wrong place. Okay, so finally a few hints. In the workbench there's some really useful shortcuts that you can use. Control space, this code completion, Shift F1, F2, F3, F9 as defined here, so that it makes working easier. So now you can get to the example and the exercise and have fun with it, and we'll come back when we look at the sample solution. Good luck.